This is the next video in the WOW series, and there's two other videos before this one where I divided up the data. So this is part 284C3k12. This is line 22f1fa19c3k12. Trans isomers, atoms, double bonds, metal carbonyls ligands 5G WOW Seti is the subject in this video. There's the alien radio signal that brought up the data. August 14th was when I started working on it, and today's September 13th. This is continued from the previous videos, so you might want to backtrack about 2 videos where it starts. WIKI notes is easy notation from trans isomers. I did a cross-reference with the WOW data and this too, okay? So BrClHCl. Bromine has a higher CIP priority than chlorine, so this alkane is the Z isomer. So easy notation, this is from Wikipedia, it's a quote. This cis-trans system for naming isomers is not effective when there are more than 2 different substituents on a double bond. The easy notation should then be used. Z from the German zusammen means together. It corresponds to the term cis E from the German Entigen, means opposite, and corresponds to trans. Whether a molecular configuration is designed E or Z is determined by the Cahn Ingold Prelog priority rules. Higher atomic numbers are given higher priority. For each of the 2 atoms in the double bond, it is necessary to determine the priority of each substituent. So I'm going to Google the Cahn Ingold Prelog priority rules to find out what it means. And the quotes from Wiki are a set of rules used in organic chemistry to name the stereoisomers of a molecule. And I found a graph here showing the different things. The different types of isomers, stereochemistry focuses on stereoisomers. Okay? Quotes from Wikipedia, again you can see that graph in Wiki. Stereoisomers are isomeric molecules that have the same molecular formula and sequence of bonded atoms constitution, but that differ only in 3-dimensional orientations of their atoms in space. This contrasts with structural isomers, which share the same molecular formula, but the bond connections and or their order differs between different atoms and groups. In stereoisomers, the order and bond connections of this constituent atoms remain the same, but their orientation in space differs. So it's a lower priority, higher priority graph here. If both the higher priority substituents are on the same side, the arrangement is Z. If on the opposite side, the arrangement is E. Size cisplatin and transplatin. 2 isomeric complexes, cisplatin and transplatin. That's the diagram for them. And there's these diagrams here. That's the calculation for that. Tells you what it is. And there's this picture. Iron tetracarbonyl. Look at that. It's got 5 points to it. Okay? An iron atom with 5 co-ligands. Quote from Wiki. Metal carbonyls are coordination complexes of transition metals with carbon monoxide ligands. That's what that is. They occur as neutral complexes as positively charged metal carbonyl cations or as negatively charged metal carbonylates. The carbon monoxide ligand may be bound terminally to a single metal atom or bridging to 2 or more metal atoms. These complexes may be homoleptic, that is containing only co-ligands such as nickel carbonyl. And there's the calculation there. But more commonly, metal carbonyls are heteroleptic and contain a mixture of ligands. Metal carbonyls are useful in organic synthesis and as catalysts or catalyst precursors in homogeneous catalysts such as hydroformylation and rep chemistry. In the Mond process, nickel carbonyl is used to produce pure nickel. In organic metallic chemistry, metal carbonyls serve as precursors for the preparation of other organometallic complexes. Metal carbonyls are toxic by skin contact, inhalation, or indigestion, so obviously they're not very good. In part because of their ability to carbonylate hemoglobin to give carboxyhemoglobin, which prevents the binding of O2. So, September 13, 2012, formula ideas from the keywords in this video's data. So we have trans isomers plus bromine plus Z plus E plus double bond plus together plus opposite plus trans plus molecular plus higher atomic numbers plus Cahn Ingold Prelog priority rules plus 2 atoms plus in a double bond plus stereoisomers plus molecule plus isomeric molecules plus formula plus sequence plus bonded atoms plus structural isomers plus molecular formula plus bond connections. We're going to add iron pentacarbonyl plus iron atom with 5 cold ligands plus metal carbonyls plus complexes plus transition metals plus carbon monoxide ligands. Then we're going to add some positively charged plus metal carbonyl plus cations plus negatively charged plus metal carbonylates plus carbon monoxide ligands plus bond plus single metal atom plus bridging plus 2 plus more plus metal atoms. We're going to add the homopoleptic plus CO ligands plus nickel carbonyl plus same thing plus synthesis plus catalyst plus precursors plus homogeneous catalysis plus hydroformylation. So I'm going to Google that to find out what it means. Rep chemistry, I got to Google that. Mon process, I have to Google that too. Nickel carbonyl plus pure nickel plus organometallic chemistry plus metal carbonyls plus organometallic complexes plus the metal carbonyls plus carbonylate hemoglobin plus carboxy hemoglobin. I'm going to Google that plus prevents plus binding plus O2. So I'm going to Google these keywords in the next video series. The hydroformylation, rep chemistry, Mon process, carboxy hemoglobin. So I'm going to explore these keywords in the next set of videos. Thank you for watching. I still have to do the research on them, so it might be another week or so before I get them out. Thank you.